Hi, my name is Sarah. I'm a junior here at TOPS, and in this video, I'm going to be talking about the substitution method for solving a system of equations. So, first of all, when a system of equations asks you to solve the system, it wants you to find the variables in the system. And that's meaning both variables. So in this case, it'd be the y variable and the x variable. So firstly, for the substitution method, you need to find the value of one of the variables. And by value, it's not necessarily just like the constant or just like a number. It can be a term like this, where it has another variable, but because it's the same variable as this other variable here, then you can combine those and simplify the equation. So with this problem, we're given the value of y. It's equal to 2x minus 5. So with the substitution method, you would take that value that you are given or that you found, and you would substitute it in place of what it is equal to. So for example, instead of inputting, just leaving it as is with 5x minus 4y, you would put 5x minus 4 times the value of y. And in this case, the value of y is 2x minus 5. So you would write 2x minus 5 instead of just y. Okay, so now the next step would be to distribute to kind of get rid of this parentheses. So it's negative 4 times the parentheses, so you would distribute the negative 4 to each of the terms in the parentheses. So 2x is one term, negative 5 is one term. So you would multiply negative 4 times 2x. That would give you negative 8x. And you still have the 5x from earlier, nothing happened to it, so you'll just include that in the equation. And then you would go back to your distribution, and you would distribute negative 4 to negative 5, and that would give you positive 20, because a negative times a negative makes a positive. And you still have your negative 10 on the right side of the equation. So now I can combine like terms, and I'm just going to start by combining this 5x with the 8x, or the negative 8x. And if I combine that, that gives me negative 3x. And so there's no other like terms on the left side, so I'm just going to add the 20. And I still have the negative 10 on the right side. So my goal here is to isolate this x variable. I want to get x alone so that I can find its value. And to do that, I'm going to use inverse operations, and I'm going to just move all the constants to one side. And I can, if I subtract both sides by 20, then that leaves me with, that just leaves me one step closer to isolating x. So that cancels out the 20 there. So I just have negative 3x on the left side and negative 10 minus 20 on the right side, which is equal to negative 30. So again, I'm trying to just isolate the x. So I would use inverse operations to get the x alone. And in this case, I would divide both sides by negative 3, because that would cancel out the negative 3 up here and leave x alone. So if I divide the left side by negative 3, that cancels out the negative 3 and leaves me with just x. And if I divide the right side by negative 3, then I get positive 10, because negative 30 divided by negative 3 is equal to positive 10. So if I just go to up the right side of the board, that I have x is equal to positive 10. Now for the next step, so given that what we found is equal to x, which is 10, I can use that value and I can plug it into either one of these equations. I'm going to go with the second one. So I'm going to plug in that x value of 10 into the equation. That gives me y is equal to 2 times 10 is minus 5. Now I just simplify. That gives me y is equal to 20 minus 5, which can be simplified further into y is equal to 15. So that would be my solution set. I know X, I know Y, I'm good to go. I just gotta check my answer. So I'm just gonna write my solution set 10, 15. And to check my answer, I would plug my values into one of the equations, one or both. I'm just gonna do one. And I'm just gonna plug in the values that I found, make sure the equation is true. So in this case, I would do 5 times the value of, this is the first equation, by the way, but I would do 5 times the value of x, which is 10, and then I would do minus 4 times the value of y, which we found to be 15, and that would be equal to negative 10. But I don't know that yet. That's what I'm trying to find. So I just simplify. I have 5 times 10 is 50, and I have negative 4 times 15 is negative 60. And I have that is equal to negative 10. And if I just solve the left side, I have 50 minus 60, which is equal to negative 10. So my solution set is correct because this equation is true. So the solution to the system of equations is 10, 15.